Good morning, everyone. My name is Sandeep. My presentation on a shortest path the approach for routing in space networks. We can see the introduction to shortest path tree approach for routing in space networks. It approaches as a fundamental technique used in space networks to efficiently route data packets. It helps in finding the shortest path between any two nodes in a network, minimizing latency and maximizing throughput. By constructing a tree rooted at the source node, this approach ensures that each node is connected via the shortest path and tree approach for routing in space networks. And we can see the next slide. The importance of shortest path tree approach in space networks. In space networks where communication links are constrained by distance and limited resource, efficient routing is crucial. Shortest path tree approach optimize the routing process, reducing the overall network congestion and increasing reliability. By selecting the shortest path, minimize the signal propagation delay and energy consumption in space communication. This is the importance of shortest path tree, and we can see the what are the key components of shortest path tree approach. Three main components include the source node, destination node, and intermediate nodes in the networks. Each node calculates the distance from the source node to construct the shortest path tree. The approach utilizes algorithms like Discrete or Bellman-Ford to determine the shortest path and build a tree structure. These are the key components of shortest path tree approach. These are the main 3 points, and we can see the what are the advantages of shortest path tree approach in space networks. It provides a scalable and efficient method for routing data packets in large space networks. By minimizing the number of hoops and delays, it improves the overall network performance. The approach is adaptive to dynamic network conditions, ensuring optimal routing paths at all times. These are the advantages of shortest path tree in space networks. Now we can see the next slide. Challenges in implementing shortest path tree approach in space networks. Space network face challenges such as high propagation delays, link disruptions, and limited bandwidth. Dynamic changes in network topology require frequent updates to the shortest path tree, adding computational overhead. Security concerns and ensuring data integrity are critical aspects that needs to be addressed in implementing this approach. These are the challenges in implementing shortest path tree in space networks. We can see the next slide. Case study. Applications of short path tree approach in constellations. Shortest path approach is used in satellite constellations to optimize inter-satellite communication links by establishing efficient routes between satellites. Data can relay quickly reliable across the constellation. The changes dynamic satellite environments. We can see the next future trends and research direction in shortest path approach for space networks. Research in is ongoing to enhance the scalability and efficiency of shortest path tree algorithm for space networks. Machine learning and artificial intelligence techniques are being explored to optimize routing directions and adapt to changing network conditions. Integrating quantum communications principles and protocols may lead to advancement in secure high-speed routing in space networks. Integrating quantum communications principles and protocols may lead advancement in secure and high-speed routing in space networks. These are the future trends and research directions. You can see the next slide. Comparisons of shortest path tree approach with other routing algorithms in space networks. Compared to traditional algorithms like flooding or random routing, shortest path tree approach offer better efficiency and lower latency. It outperforms distance vector routing and linked state routing algorithms in terms of path optimization and resource utilization. Hybrid approach and this improve network performance space environment. You can see the next slide. What are the how we implement challenges and solutions for shortest path tree approach in space networks? Issuing large long distance space communications require advanced routing protocols and optimization techniques. Overcoming signal degradation and interference in space environment is crucial for maintaining reliable connectivity. Collaborative effect among industry, academy, and space agencies are essential to standardize and implement efficient routing solution based on the shortest path tree approach. These are the implemented channels and solutions for shortest path tree. Overcome signal degradation and interference in space environment is crucial for maintaining reliable connectivity. You can see the next slide. This is the conclusion key is shortest path tree plays a vital role in optimization. Shortest path tree approach is an important role in optimizing space network, ensuring efficient data transmission and network performance. Despite challenges, ongoing research and advancement in technology are paving the way for more robust and adaptive routing solutions. By leveraging the principles of shortest path tree algorithms, space networks can achieve seamless connectivity, reduce latency, and enhance its communication system. This is the My name is Sandeep. I am from Computer Science Engineering. Uh, Thank you.